Okay, let's kick off. Firstly, thank you, everyone who has signed up and has joined us today. And I know there are some people who've registered who can't make this session. There will be a live recording, so you can always catch up if you have registered. Really excited to be doing this webinar today, which is going to be how to bootstrap enterprise taxonomies for auto-categorization. And it's also kind of an introduction to Graphite Knowledge Studio. Done a little bit of talk about Graphite Knowledge Studio last year at end of year at KM World, but this is going to be the more in-depth presentation about that. I am joined today by Borko from Ontotext, and I'm going to do the introduction section. Hey, Borko, do you want to say hi?
Yeah, thanks, Dave. A million thanks for inviting me to speak to this webinar, and looking forward to it.
Great, thanks, Borko. So let me just say a little bit about what we are doing and what we're not doing today. So what we're going to cover today is, so this slide has kind of the big picture of categorization, extraction, ML, big graphs, etc. We're going to focus today on the first two things, inline tagging, semantic tagging, categorization, and classification. The topic is too big to get everything into one webinar, so we're going to have either one or two more webinars where we look at other things, including extraction, machine learning, big graphs, and these additional topics. But today we're going to focus right here on course kind of tagging and categorization activities. Let me tell you a little bit about Synaptica. So Synaptica has been around since 1995. We're a very mature business in the taxonomy management space. We started working with the publishing industry, so big academic publishers, and over time we have kind of diversified in terms of the clients that we're serving, and that goes all the way through enterprise content, science, engineering, media, etc. Today, we're getting really interesting new clients in industries we'd never have dealt with 25 years ago, like apps for fashion and hospitality and food delivery and so forth. So a real diversification. Now, with that diversification, there has been a shift from people just doing what I call information science, and that means things like taxonomy, thesauri, traditional kind of info science discipline, to information science and data science. And that's been a gradual shift, and kind of addressing that shift is part of what we've been doing in the last few years. And one of the reasons we have a deep alliance with Ontotext. Let me talk a little bit about the distinguishing characteristics between information science and data science. Information science on the left is about human curated knowledge. It's very much a top-down description of knowledge. Taxonomies are themselves an attempt to categorize and subcategorize and classify. Information science is very human readable. So when we create taxonomies, we're creating human readable representations of knowledge. And by one of the essential qualities of information science is defining a world of knowledge. So it's defining. Data science on the right here is quite different. It's computationally based. It's bottom up, based on extracting, reading lots of different data sources and extracting information. It's necessarily machine readable. And the big distinction between it and information science is data science is here to help you infer knowledge as opposed to define it. Now, bringing these two things together is a sweet spot, and that's what we're trying to do with Knowledge Studio. It's also the relationship we have with Ontotext. So Ontotext have over 20 years in the RDF graph space, deep experience in NLP and text analytics, And essentially, there's a lot of data science talent at Ontotext. Synaptica, 25 years, we're really deep in information science, control vocabularies, taxonomies, and ontology. And we're bringing these different technical resources, these different perspectives together in the product that we call Graphite Knowledge Studio that we're going to be looking at today. Quick agenda set. I'm going to spend the first 20 minutes, and I've spent some of them already, doing some general introductions and also talking to you about some framing, what it is you're going to see, quick key concepts of what you're going to see, and kind of how we're attempting to build a user experience to help people do this kind of work. I'm then going to hand over to Borko, who is going to do showcase examples, and he's going to do showcase in two areas, e-commerce and jobs and skills, job listings. Then he's going to hand back to me. I'll try and do a wrap up and summary, and we'll have some Q&A time. Now, we may have very little Q&A time, and the attendance is quite high. I'm just looking at the count. We've got 100 people logged in right now. So what we'll encourage you to do is post questions at any time in the Q&A. And we may not get your questions on this live session, but what we will do, and what we promise to do, is anyone who posts a question, we're going to get back to you by email with answers to your questions. So post away, whether we get to you or not, it's not wasted, and we look forward to answering all your questions. Okay. Almost all enterprises that are doing enterprise taxonomy are using SKOS. And I say almost because there are clients we work with who have based their taxonomy work on OWL classes, subclasses, named individuals. They're supported in Graphite as well, but most clients that we work with are using SKOS. So what I wanted to do here is just say, what does SKOS look like, super high level, and what can it do for you in terms of auto-categorization? So I've got a slimmed down version of the SKOS schema here. There's other stuff here to do with, documentary notes and fields and so forth. But this is the essential stuff that could be leveraged in some way in the categorization process. So SKOS identifies concepts as belonging to a concept scheme, which AKA is generally called a taxonomy, a discrete taxonomy. Those schemes become, or can become, what we would consider as metadata facets. They provide the control vocabulary values of specific elements of metadata that you may want to tag content with. So a concept scheme is an important part of auto-categorization as being a container of categorization concepts. Concepts themselves are, of course, the core of this. And a concept is going to not just be a string. A concept is a thing. It has unique identifiers, and in SKOS world, these are HTTP URIs. And these concepts are the thing, the granular thing, that means you can categorize content not by string metadata, but by thing metadata. Really important distinction. SKOS also provides hierarchies, and those hierarchies are very important because they can enable you to do classification-based roll-up. Simple example, I've tagged a document to apples, pears, and bananas. The hierarchy tells me they're generally about fruit. I might want to roll up and classify a document about fruit based on the evidence of more specific things. So a simple thing in SKOS allows you to do these kind of classification roll-ups. Now, let's get into the label world, because this is very much where the action happens in terms of categorization. So pref labels are all important in taxonomy management for the human readable, unambiguous label for a concept. Generally speaking, those human readable, unambiguous labels are not necessarily the wording that you will find in text. And so they don't necessarily map well for a categorization engine to use. Good thing is SKOS provides alt labels, hidden labels, and you can load those in with alternatives, words, phrases, etc., that do represent what you find in text. Definitional notes and scope notes, other kinds of notes, in SKOS, they're all there, they're all helpful, they give context, but they're giving human readable context that's not really easily used by machines. So let me summarize where we're at now with SKOS, which is the go-to taxonomy management schema, and categorization. Good for, on the left, it's good for managing concept schemes, which you can use to identify your metadata facets. It's good for storing alt labels, hidden labels that can expand the number of matches that you find. And I note here candidate matches, because just because you find an alt label in a piece of text doesn't mean it's contextually validated or about that. And of course, we've got this classification aspect through the hierarchical structure. On the right, not good for. It can't support, the SKOS schema can't support a way to say, I'm going to give you some contextual evidence here to say that this is or isn't about something. It just doesn't have a framework for that. It doesn't have a framework for doing things where you're not looking for a specific word or phrase, but you're looking for a pattern. And pattern-based entity extraction is a very important aspect of the auto-categorization, because you don't always know, you can't always name everything, but you can identify patterns. And SKOS doesn't support things that categorization engines use as well, like proximity, relevancy ranking, rules, and other indicators. So these things are missing now. Of course, we have tried to address those. So in Graphite Knowledge Studio, what we have is we have an ontological schema extension that we can connect with SKOS that stores all the missing elements that let us do these things. So everything that was red on the previous slide is now green, because we can do it through these extended data properties and other ontological properties. I've grouped these into three. I'm not going to go into everything here, but basically the first set are give the taxonomist simple natural language keywords and phrases that they can add to say this is about something, it's not about something. Give the taxonomist the power of pattern-based matching through a simple syntax, well, simple or difficult syntax depends on how you're experienced with it, but regular expressions are widely used in a lot of different businesses to store pattern-based search and matching criteria. So we've added those into the tool set in Knowledge Studio. And also we have here things for tagging properties like relevancy rule, proximity, etc. All the kind of nitty-gritty stuff that categorization engines need. This slide is going to talk about, or on this slide, I'm going to talk about the kind of the workflow, the overall workflow that we have tried to build here in Knowledge Studio. So we obviously need a place where we can design our taxonomy schema, our ontologies, and you can start with SKOS, you can start with OWL, but whatever you start with, most businesses extend those schema with custom extensions for different data properties and relationship types. So that's a key part of managing managing ontologies and taxonomies, is being able to control the schema. Graphical user interface for that, it basically lets you do all of that without even knowing what RDF is, or basically it's all GUI driven. Next up is developing and managing and curating those taxonomies. These are the things that become the facets of metadata that you will tag content with. The central area here is called out with a loop, because the human in the loop is absolutely critical. And this is whether you're doing machine learning, pure machine learning, or you're doing rules-based, pure rules-based, or some kind of hybrid. Human in the loop is essential to getting high quality auto-categorization and classification. So there are three elements to this that we've called out, and Borko is going to show you screens that illustrate all of these. So you'll kind of see the principles that we're looking at here. After developing the taxonomies, we want to run those against corpora, and we want to evaluate the annotations, bring up documents, see how they've been tagged. things will be good, some things will be bad. Intervene by deleting or adding or saying, I need to loop back and refine the rule in the taxonomy system. And then through this iterative human in the loop process, you're able to see the results instantly, intervene instantly. And what we're ultimately doing here is establishing ground truth. And I'll explain that term on the next slide. Well, that's a little bit over to the far right. I'm not going to go down to the automation of pipelines, but I want to talk about building a knowledge graph. Enterprise knowledge graphs are the buzzword of now, in a way that I haven't always been a fan of hype cycle phrases, including artificial intelligence, which is basically overused. But enterprise knowledge graphs is a buzz, and there's a good reason for it to be a buzz. It's absolutely empowering. And Graphite Knowledge Studio is here to help you build enterprise knowledge graphs. What we are going to show you and what I'm going to highlight at the very end is content-aware knowledge graphs. And what do I mean by that? I'm going to explain that better at the end. So well, I'll let Borko kind of show you, and I'm going to return to content-aware knowledge graphs as kind of a closing thought, really, really important piece of this whole workflow. This slide, and I saw out of the corner of my eye, there's a question about, will slides be available? They will be available. This slide, I'm not going to read these by any means, but I need to do some jargon busting with you. So one or two things I will dip in here. When we say annotation, we mean tagging. We mean anything where we're picking out a span of text, a word or a phrase in a document, and we are tagging that with a concept or a rule or something from the taxonomy. So that's broadly what we mean by annotation. Different people use different words for that. Corpora just means a bunch of documents, a collection of documents that you feed into the categorization process, run trials over, or maybe you actually do a production run over, but it is a body of documents, and they may be, as I say, used for either trial purposes or production. Aboutness, my favorite word. Aboutness is really compare and contrast with inline tagging. So inline tagging, it attempts to identify the many concepts that are mentioned in a document. Aboutness tagging is trying to find the few that represent the overall aboutness of a document. It is a measure harder to identify the aboutness of a document than it is to identify the specific things that are talked about in a document. But these are two concepts, and you're going to see both things illustrated when we switch over to Borko's live demos. Explainability. This is an important feature of everything we've tried to put in Graphite Knowledge Studio. There are systems which do categorization, and you really have no idea. They're often kind of referred to somewhat pejoratively as black box systems. They do the tagging, they do the categorization. You don't know why they made the decisions that they made, and you really don't have what we call explainability. So in Graphite Knowledge Studio, we're saying explainability is key, and let's build screens, let's build widgets and so forth that make it easy for people to understand why the categorizer made the choices that it did, and then intervene if you don't like it, if it's got it wrong, or if it's missing something. Make it easy to intervene. So explainability is all about that. Ground truth, I mentioned that before. Through using Graphite Knowledge Studio and a corpus, the human in the loop is able to take examples of content and improve the tagging, and the system is going to know, if you like, learn from what these changes are, things that were missing, things that have been added. And there are reports and tools in Knowledge Studio that will let you do a comparison of ground truth, which is human validated data, or could be an imported data set that's previously been validated in some way, a ground truth data set with what the categorizer just did. And there will be metrics charts generated that help you see and understand how close is the automatic indexing to your ground truth. And that's something that we're going to have a look at in illustration. Okay, I think, yeah, I'm going to skip over those other definitions, and I'm going to hand over at this point to Borko to lead with your two demos. Thank you, Borko. I'll stop screen share for now.
Yeah, thanks, Dave. So I'm sharing my screen, and hopefully you can see it. If you could just confirm that you're seeing it.
Yep, we can see it, Borko.
Great stuff. Okay, so let me actually show in practice what you mean by all of the concepts that you outlined. Just to reiterate what you're about to see, basically going through the workflow that you explained in detail, Dave. But first off, we'll show you how you can define the taxonomical data based on that taxonomical data and taxonomy schemes that you can define in Graphite. No-code text analytic services basically instantly created based on that data. You can use that service in order to process your content, perform the tagging over it. You can then use the human-in-the-loop interface in order to establish the ground truth, basically specify the ideal quality that the text analytic service should reach and can be measured against. You can see the discrepancies between what the human user has specified and what the text analytic service returns. And you can apply corrective actions in order to basically bring the two closer together. So for the first example, we're focusing on e-commerce example, really. And the content is phone posting, so basically detailed specifications of mobile phones. Thus, what we've defined in terms of domain model and taxonomical data are a bunch of taxonomies that represent various parts that you would expect to see in a modern mobile phone. As an example, let's look at the GPUs. We see here that we have two brands of GPUs, Adreno and Mali brands, and within the Adreno brand, we have some instances of GPUs. If I open one instance, you can see stuff that you would expect to see in SKOS, such as broader and narrower, pref labels and out labels. And then you can see the additional properties that we've built upon the foundation of SKOS that enable us to really have a high amount of control of the performance and output of the text analytic service. How this transfers into the human-in-the-loop interface, let me open it right now and go into the configuration, because a key point is that basically various use cases are supported. This is a horizontal product knowledge studio, and the specific application or verticalization, specialization is really defined by the taxonomical data that you define in Graphite and the content that you process. So over here we have, in terms of configuration, basically we can define the concepts or a subset of the concepts from all of the taxonomies that we have in Graphite. We can define the various properties of the documents themselves or the content that we're interested in processing. And we have two types of annotation. One is document annotation. We'll see those in the other example. And inline annotation, basically inline tags of specific mentions of concepts in the text. And as you can see here, those are basically identical to what we showed you in terms of taxonomical data. So in order to see this in practice, it's best to look at the content and the results. Over here, we have an evaluation data set that contains 10 documents. And those documents, they represent, as I said, mobile phone descriptions. Let's focus on the Samsung Galaxy S9 document, since that phone is actually quite dear to my heart. And when I open this document, I see the document view. The document view represents the basically human-in-the-loop interface, which provides the end result of the text analysis service, and is also used by the human to mark and establish the ground truth. As you can see, there are some annotations already available in the document view, represented by the underlines inline. And what I can do is I can show you how you can easily establish the ground truth. In order to do that, I just highlight the label and I choose what type of annotation this is. The Adreno 630 is a GPU annotation, and I can open the search interface in order to query the taxonomical instance data and find the correct instance. Notice that the label said Adreno 630. I'm making a mistake on purpose, just to illustrate a bit further down the line. Yeah, basically, using a simple highlight process, you can mark the human benchmark or establish the ground truth. Please note that we have a lot more annotations over here, but I've just turned those off. So, for example, CPUs, display resolution, display size. I just want to focus for simplicity reasons on the GPUs and the display types. So now that I have the human benchmark established, or the ground truth, and I have the output of the text analytics service as is, I can actually perform an evaluation in order to basically start an evaluation process and to have an aggregated view of what I have achieved with my text analytics service. I can do that by going to the reports, and let's focus only on the F1 quality report, which is the one that would basically give me the quality of my tagging service. I can choose the ground truth over here, which is my own human annotations, and I can choose what I want to measure against them, the output of the tagging service. Since we only focused on GPUs and display types, let me just select a subset of all available annotations over here. And let me specify that I want not only the tagging, but I want the entity link or the taxonomical instance ID to be taken into account when producing the quality scores. As you can see, this is all quite flexible, so you can really have a number of faceted views in the data regarding, depending on what's important for the use case. And you can also save this and access it in history for future reference. But let's focus and keep it simple now. Once I generate the report, I see some charts and metrics. And the key takeaways here are to basically see that we have a number of false positives and false negatives. And this is reflected in the precision recall and F1 scores. As you can see, those are quite high actually, but there is always room for improvement. So going back to the document, over here we see a list of all of the documents in my evaluation corpus, and a breakdown of true positives, false negatives per document. We focused on the Samsung Galaxy S9 phone. So let's open that document to see actually a like-for-like comparison between my own annotations from the ground truth and the output of the text analytics service. So what we see is that for some of the annotations, there is indeed a match, a true positive between myself and the tagging service. But then again, there is some discrepancies. We have false positives for amulet. And if you remember over here, we actually had a super amulet. So amulet is a subset. The amulet label is a subset of super amulet. And the human hasn't really marked it. It's obviously the human is more intelligent than the machine. So the machine made a mistake here represented by the false positive. We also have a discrepancy here in the Adreno case, where the same label is annotated by both the machine and myself. But if you remember, I made a mistake on purpose. So since I chose to include the instance link in part of the evaluation, that's where the discrepancy comes from. I can go back to the document itself in order to really complete the feedback loop and apply corrective actions. And indeed, I can see over here that I have the amulet label identified. Before that though, let me fix my own mistake and open the Adreno, that one. Open the Adreno annotation, the GPU one, and deselect the incorrect instance and select the correct one. Thus, I'm improving the ground truth dataset basically. And this is all persisted once I save. And the higher quality ground truth data that I have, the more confident I can be that I'm measuring my text analytics service against really a good quality data set. If I want to apply a corrective action to the text analytics service itself, though, I would then investigate in more detail the amulet label and why it was returned. And I can do that by following the link over here and being redirected directly to Graphite. So obviously there is an amulet instance with that pref label. There is also a super amulet instance with a super amulet pref label. And what I want to do is I want to say to the text analytics service that if a super amulet label is encountered in the text, please refrain from attaching the amulet instance annotation and tag over it. Because obviously in this context, those are two separate things. What I can do is I can utilize the must and must not match rules, which are basically filtering rules that specify and really configure the behavior of the tagging. So what I can do is I can say super amulet in this case in terms of must not match. So each time a super amulet label is matched, it would match to the super amulet label and not instance and not to this one over here. I can save this and the changes are instantly reflected and really it's a live integration with the text analytics aspect. And I can go back to the human in the loop interface and I can schedule another annotation job so that I see what the results of my fine-tuning of the text analytics service have produced. Over here, we can specify and trigger an annotation job. We have two types of annotation jobs. One is the tagger, which we saw just now, but then there is the explainability tagger, which gives, think of this as a debug mode, really. It's very useful in order to make sense and see the causal relationships between what the text analytics service has produced and why it has produced it the way it has produced it. If I go back to my document, I can see now at a glance that the amulet annotation is no longer present. But if you're wondering what exactly happened with it, we can enable the explainability information. So over here we have this thing called lookups, and this is only visible in debug mode. And this basically highlights all of the candidate matches that the text analytics service has produced in some of the previous stages. Please note that those are absent from the final output. So they are being filtered in various steps, basically taking into account the input that the human user that's in the driving seat of the text analytics has provided. So specifically regarding the amulet label, that one is filtered out because we have a must not match rule. And this results in a certain filtered out label. If you can, I just enabled the filtered matches and you can see that this match over here, if I highlight it, I can see a human readable string that says this annotation was removed from the output, final output of the service because of a certain rule that the human user has input. In order to complete my human in the loop process, I would like to actually evaluate at scale what my changes really brought to the table and what impact they had overall on the whole corpus. So in order to do that, I can go back and re-annotate, sorry, not re-annotate, but go to the reports once again. I'll just reapply my configuration. And if you remember, we had 90-something F1, and we also had a couple of false positives and false negatives. So again, I want to focus on GPUs and display sizes. And again, I want to take the entity links into consideration because if you remember last time around, there was a discrepancy between the entity links of my annotations and the text analytics service annotations. Right, so once I do that, I can see that there are no more false positives and false negatives, and I do get an improved, in this case, a perfect F1 score. So that concludes the first example that we had with e-commerce. The other example is slightly different than this one, and it's based on skills and job postings. So in order to show you the other example, let's first start again from the instance data and the taxonomies. I'm opening up the two environments and going into Graphite, you can see that there is this SKOS project over here. And the key point here is that really any SKOS-based taxonomy that is available out there, you can reuse as we've done in this specific example. So we've taken skills and occupations directly from SKOS and imported them into Graphite Knowledge Studio. And doing that, the same moment we do that, basically instantly we have a text analytics service that based on the labels of ESCO can perform annotation tagging against skills and occupations. As you can see, in terms of ratio, the vast majority of the taxonomical data over here is reused from ESCO. We've enriched this with additional data on top of it, such as various data points that you would expect to see in job postings, benefits, compensations, locations, etc., etc. And let me log in over here and show you how a process document looks like. Before we do that, though, we said that it's all configurable. So I won't go through the whole configuration once again, just to reiterate that in this example, we don't have inline tagging. We have document level classification. As you can see, we classify documents based on these types and these taxonomies that we have defined in Graph. In terms of content, what you see over here is, first off, we have the 700 or so documents, job postings documents. Those are all IT related in this example. Then we have a single CV. That's my own CV. As an example, usually when you have when companies are submitting job postings, they would hope that applicants would respond to that. And we have the evaluation data set. In this case, it's a single document, but I just want to illustrate how different document classification is and what the specifics are. So we have over here the various annotation facets for this document. For example, I can see that since this is a job posting for a senior software developer, we have skills from ESCO such as digital competencies, jQuery, .NET, etc., etc. We have locations extracted and various other data points such as benefits. What we also have is the explainability information, again, inline in the text. And using that explainability information, we can pinpoint why something was surfaced in the final output, as we'll see in a bit. But before we do that, what we can actually show you is what Dave referred to as tagging and rolling upwards. So as you can see, we have over here the location FISCDEL. And if I go to the other facet view of the filters, I can see that I have the various phases of the text analytics service. What we've enabled currently are the final explicit classes, and those are the classes that are produced based on explicit label mentions in the text. We also have inferred classes though, and let me give you an example of that. So for example, if I go over here and click on the FISCDEL annotation, I can enable the helpful highlight feature used in the explainability process in order to understand as an end user that this annotation was really produced because of a certain label that was matched in the text. In this case, it's the label of FISCDEL, a town in Massachusetts. That said, we don't have United States or Massachusetts anywhere mentioned in the text. Well, we do have the abbreviation, but we don't have the full name of the state. What we have, though, is we have in the taxonomy defined a relationship between FISCDEL, which is narrower to Massachusetts, and Massachusetts is a state in the United States. So we don't have in the text, but if I enable the inferred annotations, I can see that rolling upwards, we can utilize the basically inference in the graph and say that, well, actually, FISCDEL is in Massachusetts and in the United States. So that document is actually about the three of them. As you can see, there are scores over here, and the highest scoring concept is obviously the narrower one, being the FISCDEL one. Right, so if I scroll to the bottom of the document, you can see that there is salary information over here, which is not tagged. There is nothing in the compensation tagging facet, so that's just not present. And in order to actually extract that, what I can do is I can utilize some of the more expressive powers that we have built in Graphite Knowledge Studio. In order to do that, I go to the taxonomical data, see the specific instance, in this case, full salary, because that was a salary range that we had in the document. And I can actually use the must match rule to say that, well, when you encounter salary, just type it right. So when you encounter that label and a specific pattern in addition to that label, please go ahead and tag it as a salary. So I have the pattern already defined over here. Let me just copy it and paste it. Right, and paste the other one because I want either 5 or 6 digits figures. And when I save this, it's again instantly reflected in the text analytics service. Of course, it didn't save one of those for some reason, so let me reapply that, hopefully. Yeah, it's not this one. Yeah, bear with me for a second. Copying and pasting and talking at the same time is apparently not my strong suit. But now that we have it, what I can do is go and re-annotate my content once again. Please bear in mind that the whole human in the loop feedback loop of inspecting the quality against the ground truth data set and improving it, it's in full force in this example as well. We're just focusing on the expressive features that Graphite Knowledge Studio has. So now that I have my text analytics service updated, it should now be able to extract the salary as well. Let me turn it on once again via the debug mode explainability tagger. And once this is done in a second or so, I think it is done, I can go back to my document and I can hopefully see now that I also have the compensation and full salary extracted. So if I go to the bottom of the document where this was and click on the highlight feature, I can see that this highlights the 2 salary ranges listed in the document. Right. I also mentioned that we had, since we have job postings, we have a sample CV. So let me go to the CV example and talk a bit more about that. The CV example has been, that's my own CV, it has been really processed with the same text analytics service that extracts skills, occupations, locations, etc., etc. So on the one hand, I have my own applicant CV that has a certain amount of skills and of a certain nature. Basically, I have the CV's semantic fingerprint. On the other hand, I have the semantic fingerprints in terms of annotations and tags of all of the rest of the job postings. What I can do is I can utilize semantic recommendation features to say that based on the CVs that on the skills that the text analytics service has extracted for this document, my CV, please recommend documents, job postings that are looking for candidates matching these or similar to these skills. So basically utilizing recommendations based on the extracted metadata. To do that, I once again go to the annotation interface and select the recommendation in this case. I annotate with it and it should be done in a bit. And what we'll be able to see, hopefully, is a list of, really a list of documents in this case, where they are looking for certain amount of skills or documents that have a certain amount of skills assigned to them that are quite similar or relevant to the skills that I have in my document. So apparently the text analytics service thinks that I would be suitable for the software engineering manager position or software solution manager position or a senior software project manager position. So it even promotes me. So I'm quite happy with the result. Lastly, because we got into the analytics aspect, and this is really the most interesting part of the equation. Once you have the content annotated and the metadata produced for your use case, you would mostly be interested in the analytics. So we have that over here, a bunch of faceted views of the metadata already defined, such as what are the required skills. These are all aggregations, but what are the required skills for specific job roles? Or what are the required skills for specific job roles of different companies? So for example, if company A is looking for a project manager and they're looking for a certain amount of a certain type of skills, then company B may also be looking for somebody called a project manager, but they may be looking for a completely different skill set. And this is all something that you can see based on the extracted metadata. But what Dave mentioned regarding content-aware knowledge graph is what I think we would best focus on in the remaining time. And this is such a visualization. So this is my own CV, the document that we just looked at. And from that document, it has basically a relationship with a certain metadata. So this document has, and myself, I have skills such as providing leadership and performing project management. At the same time, there are companies, those are the yellow dots, that are looking for basically the similar skills. They're looking for applicants with leadership skills and applicants who can perform project management. And since this is yeah, just a small subset of the graph that we've built with our text analytics service, I can actually make it a bit bigger. So if I focus on 100 links, then we'll be able to see that the skills in higher demand are not performing the project management skills, which are only a subset, a small subset of the companies are interested in, the yellow dots. But actually, the leadership skills appear to be in much higher demand. So to reiterate, and I'll give the floor over to you, Dave, but we have via really no code and no prerequisites in terms of detailed understanding of text analytics, created a text analytics service that based on the taxonomical data can produce various and extract various data points from document and can link them in a knowledge graph. So yeah, thanks for the time, and over to you, Dave.
Thank you very much, Borka. That's great. Let me just get back to my screen share. Yeah, really good examples there. So let me first kind of go back to the workflows that we've tried to design for, and call out, you know, a summary of what you've seen. And then we'll talk about some of the kind of summary features here. But in the overall workflow, what we've just had a look at is starting with developing, curating, managing enterprise taxonomies. One of the things that many people on this call will be doing, and certainly many of our clients and enterprises we work with are doing. So an important point here is if your taxonomies are in any way SKOSified or in that format, they provide a starting place for auto-categorization. I talked at the beginning about the limitations of SKOS alone and the fact that you can go beyond that with some of the attributes that we add into the equation to improve the precision. But SKOS provides a good start. And by the way, if your taxonomies aren't in SKOS, if they're in the Excel format that many enterprises have proto-taxonomies before they hook up with a company like Synaptica or some of our competitors in the field, you can SKOSify those Excel-based taxonomies pretty much instantly and bring them into a tool like Graphite. So managing the taxonomies we've seen from Borka. Next thing around that central area is we talked about in the workflow, we've talked about being able to evaluate annotations and refine the rules. And this is kind of really an iterative process of the human in the loop. So Borka showed you different screens for looking at individual documents, turning on and off. I want to see this, I don't want to see that. So filters are very important to get the sort of zoomed out view or the zoomed in view of how tagging is happening within documents. You can click on any of those inline annotations, find out more about them, the rules that triggered them or the rules that didn't. And this whole process of evaluating, of the human in the loop evaluating, is essential to getting quality tagging. Now, there are different ways that you can then interact with this. You can say, you know, it's getting false matches here because it doesn't have enough to go on. I'm going to through a click, you can go into editing the concept in Graphite and add a rule, a must not rule, or a must rule, or something. Borko added some rules in regular expressions, which are very powerful where you don't have a precise term you're trying to map. But you can do that just with simple keywords. We've tried to create, in the Knowledge Studio toolset, we've tried to create a broad franchise of tools for different types of users, whether you are a content manager, a taxonomist, a data scientist. There are tools in the suite that are designed to help you. So not everyone wants to be doing regular expressions, but they do give some power. The next thing in this human in the loop rotation here is that bottom one, which is, okay, I'm inspecting how the tagging's going, I'm intervening. I wanted to run some analytics. I want to see how my different corpora are behaving. And as you establish ground truth, as you make improvements to ground truth, you've both got a resource there that is going to ensure that if you just stop there and run this over production quantities of data, you're going to know the kind of results that you're going to get because you've done this analysis over the corpora. You can also use this to drive machine learning processes. So the ground truth that you establish here can help with that. So these are all part of that central area that Borko has illustrated with the key aspects of developing taxonomies, inspecting, refining rules, looking at the analytics over the corpus. Now, the last little area I want to pull out here is what I call building a content-aware knowledge graph. This is really, the graph is not just knowledgeable about the ontology. It's not just knowledgeable about the taxonomy. It's knowledgeable about the things that you tagged. And this is what I mean by content-aware knowledge graphs. So when you have that awareness in the graph, wow, you can do really, really cool things. You can do cool analytics, you can do cool discovery. In this particular case, we were able to run something called a semantic similarity search. It uses something called semantic vectors, but they basically, if you were trying to do this, if you were trying to match people to jobs, people's resumes to job postings without a graph, it's a really heavy lift. Trying to do that through relational, let's say, database queries, a really heavy lift. What we can do when we graph this is we can do these semantic vectors, which will, I think, Borko, you described it as a semantic fingerprint, which is a really good analogy. There's a fingerprint of the sorts of things that a CV, a resume is about. There's a fingerprint of the semantics of a job posting. And what the graph does incredibly well is identify best matches based on similarity without you having to go and say all the parameters. It must have this, it must have that. Similarity matching is going to get you there. This is one of the things that we can do when we bring that content awareness into the graph. So this is a key takeaway slide, key message that I want to leave. If you are doing auto-categorization, and what your auto-categorization processes do is they get the taxonomy from the taxonomy system, and they go and say, right, here is in the content management system, I'm going to store the concepts from the taxonomy in the CMS or in a search index, and you stop there. You have done a lot towards building knowledge graphs, but you are missing a really key thing, because only when you create content awareness in the graph do you empower what's on the right side of the slide, which is being able to be an enterprise that's building enterprise knowledge graphs. And these are the things that will empower business process automation, business insights, and so on. So really, really powerful. Graphite Knowledge Studio lets you do that. It's a really key feature. Last slide here, and these slides will be available. Just some of the key features and some of the benefits that go with those features. So Borko mentioned the phrase no code. This is a solution which has GUI for everything. You can build auto-categorization pipelines. You can tune your ground truth and work with all of the things that we've shown you through user interface. So it's entirely configurable, and there's GUI for everything. It's standard space, so you can get your taxonomies in through SKOS and other kinds of formats there, or convert them into SKOS through import, and you can extend those schema. I hope you've seen that we have explainability built in. The product's always going to be improving, but we've put quite a lot of design effort into making sure that you've got explainability out of the box, so that there's no sort of, why is it doing this? We don't want that. We want people to be able to see and understand the tagging process, because that's the pre-requirement to being able to intervene and improve the tagging process. Human in the loop, absolutely core to the entire workflow. Content-aware knowledge graphs, absolutely core to the entire workflow. I'm going to leave the contact points on screen. We only have 3 minutes. As I said before, anything that you've posted in the Q&A is going to get answered by email. I'll just see if there's anything we can quickly answer from some of these. There's a question here about the number of underlying control vocabularies indicating important matches, is matching the job to the CV, CV to the job. The process of tagging, really, there's 2 stages to tagging. One is validating that the concept is genuinely being mentioned, and this goes on the labels of the concept, plus those disambiguating things like it must not have this word or phrase in it, or it must have this word or phrase in context. So this is how we kind of get the matching to say it is or is not being mentioned in the document. Determining what is relevant, what is most relevant, is actually a whole kind of, there's whole ranking algorithms that are going on here. They will be looking at the frequency of mentions. They will be looking at where in the document things are mentioned. A word or phrase that's close to the beginning generally is going to be more important or given more priority. And also we look at, we bounce back into the graph and say, where is this concept found in the graph, to determine relevance. So there's lots of different factors that go in there. We've got a question at the beginning about large language models, all the rage at the moment with, of course, ChatGPT commanding headlines. Large language models are going to see, I think, a real integration with enterprise knowledge and language models, and there's a complementarity to that. But I think if you look at what's working well and what's not working well with things like ChatGPT, it needs the domain knowledge of particular enterprises to become meaningful. So I think in answer to that first question, there's going to be a mashup between the large and the small language models. And as the questioner asked there, you know, is this about bottom up and top down? It's related to it. It's related to it. Okay, we are at 1 minute to the hour. I'm going to have to cut it off. Thank you for all these questions. Really appreciate the high attendance we've had today. Really appreciate your questions. We will answer everyone's questions through email. Thank you very much for attending. Borko, thank you for those fab live presentations of the tool. Really appreciate your interest. You can reach out to Synaptica through any of these links on screen today. And if you have registered, you will get a follow-up email. There will be a recording of this session, so you can get a recording. And of course, you know, just reach out to info@Synaptica if you have additional questions that are not posted and you want our help. Thank you, everyone. Really appreciate your time today. And I'm going to shut the session down for today. Thanks very much. Bye-bye.